Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Meaning peace and blessings upon you all. Dear students, today we're gonna deal with two ghosts. One is the abstract class and one is a interface. These are basically the two ghosts, let me make a ghost. Is it a ghost? Is it a it seems like a goat or like a mini version of a cow. Ah, cross it out. So what I'm talking about is, let's talk the business. That's abstract classes and interfaces. What interface actually is, it is a 100% abstract class. 100% abstract class. So basically interface is nothing but an abstract class. So let's first discuss about the abstract class. An abstract class means something which you cannot instantiate. I mean to say, you cannot create a object of the abstract class. Now question is hitting your brain, I know it, wait a while, that what's the use of it then, isn't it? That why would you like to make a class which you actually are not instantiating? Is it that question? I got it. So let's work on that. But before that, let me remove this clutter. Here we go. Let's, for example, you are actually developing a software, and the universe of discourse, or what you say, the mini world, is your college. Okay, the college you are reading in is your universe of discourse, and you want to develop software for a college. Actually, what will be the entities, or what will be the things which you will take care of? I mean, the records you will store of what entity? It will be like a student, okay, maybe a teacher, or maybe a employee. We can say employee. There could be a lot of things, but let's make it simple and understand a few things here. So maybe we are having a student, teacher, an employee, and other things. And I'm saying one thing in all of them, that they have a lot of things in common, like name, like address, age, telephone number. A student will have also these things. Teacher will also have name, age, address, telephone number. Okay, and employee will also have all those things. There could be a lot of things which are common in all of these, and there could be many more which are classes. So I'm actually basically want to create class employee, class teacher, and class student. But I don't want to repeat all those fields like name, age, telephone number, email ID, and a lot of things. What I do is I will create a class. Maybe I call it a person class. Now I'm creating a person class which is having the all common things. So it's a general class. So here we got a specialization on the downside, and this is the generalization on the top. And I'm having in a person class something which makes a sense, like all the common things, or some methods can also be here which will be used by all these guys, right? Now, would you like to call? Would you like to create an object of this person? That's my question. Because the person itself doesn't have any sense in our UOD. Because in our UOD we talk about students, we talk about teachers. So our real objects are teachers, students, employees, and other guys, but not the person. So person is something which is only having all the common things here. So that means I will make this person as a parent class, and I will let these below as a subclasses and let them extend from the person, so that if I have here name, roll number, so not roll number is specific to the student, like age, email ID, telephone number, all of those things, common things here. So I don't want to, I will not write that in this class, in this class, or in this class. Rather they will take it from this class. So that will be the code reuse. This is the basic funda of the what's called as inheritance. Basically, if you say if you had to show arrow, it should be like this, because this class extends from this class. UML diagrams. So whatever, I'm making a mess with the arrows. So what I'm saying is, you would not like to create an object of a person class, rather you would like to create an object of student, teacher and employee class. So in Java, we're given a keyword, what is here as abstract, as you have seen. If you put with the person class abstract, means you cannot create an object of this person type. Now this perhaps makes a sense, but it's not all about this. That abstract class is not all about that. I don't want to create instance or object of a person class, so I should make it abstract. Rather, it has a big role to play. That is about the big P. The P here means polymorphism. So we'll discuss about all these things, but before that, we need to actually gather a lot of tools to understand what is basically the polymorphism. Let's first show that this abstract class, if you want to create an instance of the abstract class, it will not be created. Then what else will be created, right? So before that, what you're going to do is remove the clutter. Here we go. So for example, I have got the abstract class person. Okay, getting me? I'm also having a class student here, right? Which is extending from the person, means it is the child of the person. It extends from the person, right? And in the main here, I have another class with my shortcut name like Jenny. I try to create first of type person a object, right? That means I'm saying of type person, what I'm gonna call as P as a reference variable is equal to new person. This is how we give birth to the object, isn't it? Calling the constructor, but straight away it will show me the error that person is abstract, can't be instantiated. So it can be instantiated. You cannot create a object of type person because it is an abstract, right? So compiler will not allow you. But if I say like person P, will that work? Yeah, it does not have any issues. If I close it down and I will use this one, it doesn't have any complaints whatsoever. So what is the difference between the two? If it's creating with the P, because some students have confusions that this P is an object, but this P is not an object. Let me show you actually the memory map. You will understand it better. Here we go. This is our stack, for example. This is our stack. Okay, this is my stack. Okay, and I'm having in it, we could have a lot of things, like we have a main, we have a this in it, but I will make it as simple that I'm having this time a P in it. Okay, I'm having a P in it. So this P is not an object. This is a reference variable. It is like a pointer which can take the address of the objects. So it's not an object. So if I say this one, P is equal to new, let's break it into two. We had P here the same way, right? And we have is equal to new person, right? This new actually does what? It goes into the heap and creates an object of type person, which is not allowed here. But if the person class would not have been abstract, it would have created a person object, and this P would have been pointing to the pointee, that is the object. Are you getting me? So this P is a reference variable which points to the object, and now the person P, if I'm having here, this person P is nothing but a reference variable. We are allowed to do that, and this is very important because this is like a placeholder where we put a lot of things for our polymorphism. We will understand it shortly, what I'm saying. You getting the situation or not? What's happening here? So we have learned here that this, if the person is an abstract class, we cannot create an object like this of a abstract class, but I can create an object of the student class. Say for example, this is my object of a student class, and I can have in a P the address of a student object. What does this use it for? We'll understand later on, but you understand, you take it here 2 points. 1 point, that I can't create the object of an abstract class, but I can have a reference variable of the abstract parent class, and the important is that this is a parent class, that this is a father, okay, of the father of I'm having a reference variable of the father, and the student is a child, isn't it? It is a child. As you could see, class student extends person, so it is a child, and I can put in the P the address of the objects of the child. This is important, okay, because this helps us in polymorphism, and polymorphism is here all about late binding. So if I'm saying late binding, what the heck is then the early binding, right? Let's understand this late binding by first understanding what is the early binding. Okay, before that, what I'm gonna do, I'm gonna remove the clutter. Here we go. So what I will do here is I will try to create here a class A, just any A, you know, just to tell you something. This is class A, and I'm having inside a function void show. Okay, maybe this is doing something. Say this is doing what? System.out.println anything, whatever you like. Maybe I'm A's body show. So it's showing us the body. Maybe the A's body is like Salman Khan. Okay, now I'm having class A, and I'm having it inside a show function, which is actually, you know, well, the show is doing what? It's just putting off a shirt and showing the body, or something else like that. But this is only a class. This is a class. This doesn't have a life, right? This doesn't have a life. This is only a specification. I have to create a object of class A. So that's what I do here. I will go here and I will say A type, make some object, is equal to using some new. So what is the OB here? It is just a reference variable, and when I say new, I'm saying compiler. A compiler make me an object using the constructor A. Here we go. So we got a newborn baby. That's OB, right? The OB is not that baby, right? OB is only pointing to that baby, because OB is not an object. OB is the reference variable which points to the object. Okay, and object is in a heap, and OB itself is on a stack. Good. Now what I'm saying is that if I here say OB.show, okay, what will happen? So let me show it a little bit diagrammatically again. This is our stack, and this time I'm having here we had something else like P also here. Okay, let it be P here, was here. Now here we got an OB. This OB was created on a stack, and in the heap we were given an object of class A. This is of class A object. It has some address. That address is in this AB. So basically this AB is pointing towards this object. So what we have the situation. Now OB is nothing but a reference variable of class A. That means it can take the address of the objects of class A, because A is not an abstract class, so it can be instantiated. You have created an object, it is ready to take the address, and also it can take the address of the subclasses. You have to understand that, right? Now what I'm saying is, I'm doing here ob.show. I'm telling compiler, give me the ob.show. But compiler in advance knows that this is the OB, right? And show is somewhere here inside the object in the method area. We have a show, and we know that we have to go from OB to the base address, and after that we have to find the show inside that. And compiler knows in advance at the compile time. That's important, at the compile time. This is very important, at the compile time. That means before running it, compiler knows that this show is to be bound with its definition, which is here. So compiler knows in advance that this is the show's definition, and I got to bind this call with this show function in advance at compile time. So no issues. So what happens here is, at the compile time, this ob.show will be actually filled with the address of the method where it is actually located, and basically what we say is it is bound, this ob.show is bound with its method definition. And this is the early binding. Why is it early binding? Because it binds it in the morning before breakfast. I'm going to say before execution time, is it or not? But in polymorphism, what we do late binding. So what the heck is this late binding? Let's understand it a bit. Before that, what I'm gonna do? Yeah, remove the clutter. How? By pressing the escape button. So very easy, no? So to understand the late binding, let's have an example here. For example, I'm having a like I had here the parent class a person. Let me have a parent class as a figure, F-I-G. This is the parent class here, figure. And I'm having various subclasses like a circle, which draw me the circle, a rectangle class, a triangle class, a rhombus class, or something like that, if I could draw it, or a trapezium class, or so on. Now all of these classes will have, for example, a draw function. We're having a draw function, right? This circle inside, the circle class inside has a draw function which is drawing a circle. Maybe it is is asking us, for example, about the radius, about the, and it's drawing the circle. And here in the rectangle it's asking for sides and all. So every class of these has a draw function in it, right? Now if I want to draw the circle, so if I go by this method, early binding method, I have to first create an object like this of not a class, this is a circle class. Then if the ob is of that type, then I say ob.show will draw ob.draw, for example here, then it will draw me the circle. If I have to draw the rectangle, I have to create an object of the rectangle, then call that object.draw. Reference variable of triangle, again creating the object of a triangle with a reference variable, and then saying that dot draw, and likewise. So that means this will be really complex, because I am, I have to create the reference variables for all of these classes, and then I call the draw. But this will not give me the the choice at a runtime, because it may be, the scenario could be there that the user will tell us that I have to draw a circle, not the rectangle, not the triangle, not these guys. So if user tell me I have to draw a circle, I have to only create the object of this and call the draw of this object. If user on the other side, maybe he will tell me that I have to draw a triangle, then I have to create a triangle object and call the draw of the triangle class, and the triangle will be drawn, right? So what I will do is I can do a little trick, that this figure class, I make a reference variable of the figure class. So f here, like person p, I had that means p was a reference variable of the parent class. Likewise, I can create a f of the reference variable of the parent class. And at the runtime, because f can take two kinds of addresses now, right? One, it can take the address of the object itself, but this class is, for example, abstract class, so there is no question that an object of this class will be created, and f will not in any case will have the address of the object of the figure class. So what will the f will then have? It will have the address of the objects of subclasses. So that means f can take the address of the, so it can act as a reference variable for the circle class as well as rectangle class as well as all these classes. So if I call the f.draw, the compiler at the compile time don't know what is this f.draw, because this f can accommodate addresses of all these guys. Now whose address is in a f will be on a runtime. This will be calculated, figured out on the runtime, because for example, if the user tells me that I want to draw the rectangle, what I will do is I will put the address of the rectangle into the f and call the f.draw. So tomorrow I want to draw the triangle. So what I do is at the execution time, actually maybe user telling me I want to draw the triangle. So what I do is I put the address of this class object of the triangle class into the f and call the same piece of code f.draw, and it will call the draw of the triangle class, because all of these are classes and they have their own draws. So which draw function, which draw method this draw call is to be bound, it is not on a compile time, because at compile time compiler doesn't know what this f.draw should draw. Should it be bound with the circle classes draw? Should it be bound with the rectangle classes draw, or triangle classes draw, or so on, right? So what compiler does at that time is it says wait, you gotta wait until execution time, when user makes a choice that I want to draw a triangle, for example, then we will put the triangle's object's address into the f. So this draw function will be then bound with the draw definition of the triangle class. Or user may have said that I want to draw a circle, then I would have done what? Put the address of the object of the circle class into the f. That means f.draw would have been bound with the circle class's draw definition, isn't it? Are you getting me or not? That's good. So now this f.draw will be bound to its definition, like here ob.show was bound to its definition here at the compile time, because we know at the compile time in advance that ob.show actually means this show, it's bound with this class. But here I don't know what it is bound with, because f is an abstract class, figure class and abstract, so f is ready to take the addresses of the subclasses. Now among the subclasses, which class's object is inside the f? So f.draw will call that. So this is the late binding, and this is also what's called as polymorphism, because f.draw is doing a lot of functions. Now this has it's actually doing me a lot of functions here. It's drawing me a triangle, it's drawing me a rectangle, it's drawing me all depending upon the scenario. It's like it is polymorphism. Like for example, I'm a teacher in front of my students. I am a son in front of my parents. I am a brother in front of my sister. So what happens is the same person, me, does a lot of functions depending upon the scenarios. This is a polymorphism. Same here. f.draw is doing a lot of things depending upon the scenario, right? And we're implementing it here by having a polymorphic reference variable. This f is a polymorphic reference variable because it can take a lot of the addresses of what the children, that they should be all children of this figure class. Then this f, which is of type figure class, can accommodate the addresses of the subclasses. Are you getting me or not? So it's time, I think it's time to draw a program, to do a full program on the abstract class. But before that, I would like to show you the memory map of this f and all. Okay, so before that, what I'm going to do is clear the clutter. Oh, you're becoming the good boys. Oh, girls as well. So let me call it a general parent class, good students. Fine. What I'm saying is that should I create in a code or something? Okay, for example, I'm saying here, let me remove this class A now here. Let me remove this also here. I am creating a abstract class person is here. It might have something in it. We will fill it in it later on. We have a student class which is extends person. So student class is child of the person, so person is the father of the child, or I can say student is a person. This is a relationship between the two. And I will create a person P. This means a reference variable of the person class, but I will drop into it new of student class. This is the beauty of polymorphic reference variable. So what's happening here is, let me show you diagrammatically. We have the P, a reference variable, and this P is of type the parent class, the father, okay, but it is not pointing to the object of the father class because father is here having in front abstract. So father cannot, this parent class cannot be instantiated, but I'm putting in it the address of the student class. Okay, so what's happening in the heap, I have an object of the student class and I'm putting in the P the address of the student class. So this P is pointing to the student class. So we have 2 points here. The P itself is of the type person, the parent class, but the object is of type subclass. So I can put that. So that's what I was saying just a while, that this P can hold the addresses of the different objects. So tomorrow I can have a faculty class, I can have employee class, which are extending the person class. So depending upon which address is in a P, right, that actually P, then if I call a method p.show, for example, it will be the show of that object, right? Okay, I think we should do a program to visualize this, but before that we needed a concept. I think we have all the tools now to go and do a vigorous program of abstract classes. So stay tuned and watch it in the next video. It's like 27 minutes or so. Until then, maybe you keep a big smile on your face, and I'm gonna say this will be the end of this segment. So see ya.